Okay, so this is going to be a very basic introduction about declarative syntax and like how it's like newly introduced by Apple, and how we are like moving towards more and more like declarative territory than like imperative one. So as we know, like we have like two programming style. We have an objective style and we have one functional style. So I think everyone knows about objective style. So it's nothing but object-oriented programming that we call it. So here, like we deal with objects and we do operations on those objects, and then we store things in those objects after performing some functions on them. So and this has all those fancy things like you can have inheritance and encapsulation and everything. So that's object-oriented programming. And there's one more thing that's called functional programming. So objective programming is just object-based programming, and functional programming is actually related to transformational programming. Here, like you don't in your entire program, you don't just deal with objects and manipulate them. You mainly have functions that are going to take some input and going to output something, and you do transformations many times to get some output. And that's like kind of like in an ideal way, if your whole program is like kind of ideal functional program, then that would be the entire program. It will be a series of transformations performed on your input. So there are like some drivers that are introduced in Swift that are pushing towards this functional programming territory. So structures are like very similar to classes, but they have like added benefit of rigidity. So in general, structures are like rigid objects. They're not like in general supposed to change. So I have called it pure classes for some reason. We will understand later, but they are not generally called pure classes, because I'm calling it pure classes. And structures are in general like very easy to reason with your code. As an example, let's say, let me just open this now. Okay, so I'll give you an example of structure. We'll take a really simple structure. That's a person. Let's comment out this initializer. So this is a person structure, and it has like three properties: first name, last name, and age. As you can see, we have this function called change first name, and because this function is going to change the property of the structure. So essentially, it's going to change the structure. So because like structure is supposed to be immutable, so we cannot define this function directly. So Swift lets us like mutate that structure with a function. So, but we have to like append a keyword called mutating, and also like we will have a variable first name. So as you can see, if we create a person, that's my name, like Pawan. And we try to print all its properties. You can see it's printing all the properties. And let's say we now try to create another person from Pawan. Let's say I have a twin brother, right? So I will create a Pawan's brother person from Pawan. And then we will try to print all its properties. It's the same. And then we will change the first name to Shravan, let's say, because the first name is different for my brother. So now we try to print the same properties. You can see like the first name is changed. Now, if we try to print the same properties for Pawan again, that was our initial person, you can see like its properties are intact. It still has Pawan first name, Dikshit. That's what we expect. So it's behaving like we wanted it to behave. But let's say if it is a class, now I just changed it to class. Nothing else has changed. The same logic we perform, and we see that yeah, indeed my brother's name is like first name is changed and everything else is same. But as you can see, the Pawan is also changed. So now Pawan also has like first name Shravan and last name and the age is same. So from this, like I want to tell you, like classes are like not easy to reason with simple codes, but structures are, because they are rigid and they perform a copy operation, and then the other object that you get, Pawan's brother, that is an entirely different object. So that's the difference between classes and structures. So let's go back to our PPT. So we have so Swift has like has introduced like structures, and they are like pushing more towards like using structures instead of classes because they are like easy to reason about. And similarly, there's another concept that is called pure functions, and like in layman terms, they are transformations. Uh, so so difference between like a function and transformation is so let me tell you with an example. Okay, so let me create this function, right, with suffix on a string, and we'll pass a suffix, and we will try to append the suffix. And let's say we have this path, some path file name, and we will append this suffix.txt, and we will print the path. You can see it's printing some path file name.txt. But this is not a transformation. This is not a pure function because it's going to change the string itself. So this path needs to be a variable, and when you perform this function on this path, it's going to change the path. But in functional programming, you don't want to do that, like in general. So you don't want this mutating keyword. So you don't want to mutate any state of the structure itself or object itself. So what you need to do is you don't have to mutate anything. You have to return a new instance of a string instead of appending to the string itself. So you will be returning after appending that suffix. So now you have this path. It need not be a variable. It can be a constant. And then we will say let file is equal to path.with suffix. Now we'll print the file. So as you can see, like it's the same output, but this code is very easy to reason with. It's just a transformation on the existing path that we have that outputted a file that we can work with. So now this is a transformation. It's a pure function. Yeah, so if we print the path is still the same. It has not become a file. So this is so this is the concept of transformation, a pure function. So they are again easy to reason about. It will form a story in your code. And the third concept is that was introduced to Swift was higher order functions. So okay. Okay, so let me again give you an example. So let's say you have these numbers, three numbers, 1, 2, 3, and you want to get the squares of those numbers. So you will create a square numbers array, and then you will go through all the numbers in here, and then append those numbers one by one, and then take a square of that number and append it to square numbers. And then you again go through all the numbers in the square numbers and print them. So this is the output that you get. Every number is squared and printed. But Swift has now introduced some higher order functions that you can utilize. So now I will be writing the same code with using higher order functions. So let me have again those three numbers, and then I'll say map into. I'll explain you those symbols, but for now you can see how this can be written. The same code can be written like this. So as you can see, you get the same output 149, but your code is now this. So you see like these are so these are called higher order functions. So map is a higher order function, and this for each is also a higher order function. So if you just write it like this is another array that will have the value of. So if you see here, right? See, this is another array which has the value of 149. So that curve has changed. See, it's printing 149 here. So the original array that we had now after application of this map will output another array that would have 149. But we would not get we would not have to create that array ourselves. So that would be the output of this function.
Okay, yeah, got it. Thanks.
And then once we have this output, we can apply more functions to that output. So we have also applied one more function that's called for each. And what that does is like that just prints the elements, but it doesn't have any return type. So this will not give you an array, but it will execute this statement for all the elements. So we will understand how this is working, right? So let's not write it like this. So we will write how it's actually implemented. So as you can see, map is nothing but just a simple function, and it's taking a first argument transform, and that transform is nothing but another function that takes an integer and returns something. So you can say it takes an element and returns an int, and then we can just return element into element. So this is equivalent to the map function, and similarly we can do for each. So it takes a body again with one element, and then we can just print that element. So this is equivalent to what was written earlier. So it again has the output of 149. So these are just functions that take some other function in the argument and do some work on it. But so now I'll explain how they can be written this compact form. So this is actually shorthand that Swift has introduced. So firstly, like you can drop these brackets, right? Because Swift compiler can still understand this. And also it can infer these return types once you are returning. So it can infer that you're returning in element into element. So what would it be? So we don't need the return type. And also if you have like in a function, if you have arguments, you can replace them by these notations. So if we say $0, that means first arguments. First arguments. Now you don't need the return type. You don't need the parameter because you can represent the first argument as $0, and also if in a function, if you have only one line, you can drop the return. So now we got the original form back. Similarly here, we know the first argument can be represented with $0, and so we can drop this argument, and now it becomes just this block as earlier. So as you can see, like these are higher order functions because they are treating functions as kind of variables and passing them around in other functions. So that's why they are called higher order functions. Any questions from anyone? So as you can see, like we have this the structures that are kind of pure classes, because what I'm saying is why I'm saying these pure classes. Let's understand that more. And pure functions. So these are just higher order functions, and I gave you an example of how a pure function looks like. And there's one example. Let's say we have this variable rewards collected, and it's currently 3. And we have a function called message to display, and that returns a string. It says like if rewards collected is like less than 5, we cannot like collect more rewards. You have to try tomorrow, or else it'll say you get a reward. So let's call this function. It says you got a reward. So but as you can see, like this is having a state inside. So this reward collected is a state that comes from outside a function, outside the function. So that's why it's not a transformation. It's not a pure function. So to make it a pure function, what we need to do is we need to pass this as the parameter. And then use that parameter to do our logic and return the string. And we have to pass that here. Similarly, nothing has changed. Output is same, everything is same. Now this function is pure. It's not using any state from outside. Now it's called a transformation. So so making it pure, as you can see, like there are like no states inside. So it's a complete stateless function. Similarly, a struct, if you see a struct, that is also by default acts as a like stateless object, because you have to append mutating if you want to change any state. So it kind of gives us a surety that if you are defining any functions in a structure, they are not going to mutate any of the state that is inside. So if you try to do that, the compiler will give you warning. You cannot assign property for sorry. So yeah, you make it var, and then also you cannot change the state. So now it says cannot assign to property because self is immutable. So because structure is immutable, if you are using structures, then it's you are quite comfortable that you are not going to change any states inside, unless you try to do that manually, making a function mutating. But then you know that you are not going to write a transformation. You're going to write a function that's going to change the state. So that's why, because pure functions don't maintain any states, so I call like structures as pure classes. Yeah, we looked at the higher order functions. So after the introduction of these structures, pure functions, and higher order functions, now we are ready to move to functional transformational programming instead of objective one. So there are some benefits that that are there with functional programming instead of objective programming. One is like code proximity, because you are not dealing with states from somewhere very far in the code or in a different file. So your logic is kind of compartmentalized. So if you are doing something in a part of a file, all of the uh, all of the logic related to that is in that part of the code. It's not that like if something changes in another file or something changes very far in the code, your function or your transformations are going to be affected because they are stateless. And you get the separation of stateful and stateless parts because most of your code is going to be stateless, doing transformations. And whenever you need state, because you will need a state in some scenario because we are dealing with UI, and UI need to maintain state somewhere. So you get a clear separation. So whenever you have a state that you want to maintain, you have to define it explicitly. And all of your other code that's not dependent, that need not be dependent on the code on the state, can be transformational. Yeah, so again, like how to try to make your functions pure, or how to make a function a transformation. It's a simple, like, so you try to use structures as much as possible. Don't try to use classes. Use classes for very specific regions when you have some regions to use them. I'm sure everyone knows a difference between classes and structures. So your mutating keyword is your friend, like in structures. So if you don't use that, you are sure that it's nothing, no functions is going to change the state in the structure. And you always operate on parameters instead of creating any state. So whenever you are creating a function, take all the required parameters. Don't try to use any properties from structures. You can use them like for but yeah, I think like the best thing is not to use any. Always rely on parameters and return a value from the function. Don't try to like modify something and expect that the caller will think that the original structure has changed. Always return a value. So that's how like you can try writing transformations and code with those. And another thing that I wanted to talk about was imperative versus declarative syntax style. So as we move to functional programming, we move away from imperative and we move towards declarative. So there's no clear distinction between imperative and declarative syntax. It's not that you can say like some syntax is totally imperative or totally declarative. It's just like fuzzy in between. So as you move towards like higher order functions, your code becomes more and more declarative. And as you keep using, as you move towards using lower level uh, elements, you move towards imperative. So imperative is something like you are telling how something needs to be done, versus in declarative you just tell what needs to be done. You don't have to tell how it's going to be done. So if we see this example that we saw earlier, so here this is a imperative, more imperative, because you are explicitly telling every step that needs to be performed to get the output. But here, as you can see, because we move to a higher order functions, you are not telling exactly how it should work, how it's gonna print it, but you are telling that I have this array and I want to get a square and I want to print it for each of them. So this is moving towards declarative syntax. No one can say it's completely declarative, completely imperative, but we are moving towards declarative. So nothing could be completely declarative. Like as we move towards more and more higher order functions, it will become more and more declarative. Any questions? Anyone? Okay, if no other questions, let's move forward. So let's take an example from our actual code that we write day to day. So this example, as you can see, this is this shows how imperative statements are written. Uh, so you have a UI view and you want to like animate that UI view. So you say UI view dot animate with duration, and you pass animation, and you have this animation where you pass what needs to be done after the animation, and that you are changing the alpha to 1. So it used to be 0, it will become 1 in 0.3 seconds. So that's the animation. And on completion, you want again to like resize that to 200 width and 200 height. So now like if we want to like write it declaratively, how will we do that? Let's see. So in declarative, we need to tell what needs to be done. We don't have to tell like how it's going to be done. So this is telling like how is having a completion block where you are setting button dot alpha is equal to 1. You're telling it like what to do, and with all that duration, and then you have the completion block, and where again you are telling you have to assign the frame size to width and height. So in declarative, you just tell like what to do. You have this button again, so you call button dot animate, and then you pass an array, and then you say fade in with this duration, and then resize to this width and height with this duration. So that's a declarative statement. You're telling what to do instead of how to do it. But as you can see, like this is not going to this is not like that we don't have this implementation. We would have this implementation inside the functionality of this animate. So that code is not gone anywhere. So that code is just got like hidden from us in the libraries to make it more declarative. So from a developer perspective, this became like less error prone, and all the functionality, the actual implementation details are in the library. and that implementation detail can change, but this declarative API would remain the same. But if you are writing in the imperative way, because developer has to write these statements, they can do some pitfalls, and also they may write some unoptimized code. Versus if we have the declarative API, you don't have to worry about the implementation. You just use the declarative statement and system will take care of how it's done. You can also write your own APIs that are declarative. For example, this button.animate can be implemented in a way that you get this nice API, a declarative API. So why Apple is like moving towards this declarative programming syntax? Because they want to hide the implementation so that they can change implementation drastically in future, and APIs won't change. All the APIs will still work. And also this also gives them ability to write, to have like a different implementation for same declarative API on different platforms. So the declarative API could be the same, but if that runs on Mac OS, it could have a different effect, versus if it's run on iOS, it could have a different implementation or effect depending on the device. So as you can see, like all the new swiftui and combined APIs work across the platform. So they work on Mac, they work on iPhone, iPad, Apple TV, watchOS. So they work everywhere. They have the underlying code different on every platform, but the declarative API is same. And again, like it avoids pitfalls and error-prone coding by the developer itself. Developer just tells what needs to be done, and system takes care of it.